Tonight. The homework will be due on Wednesday. At the end of the week, all late work is due by the end of the week. Midterms are next Tuesday or Wednesday or something like that. So make sure you're getting everything turned in. Shh. You can check what's late on Google Classroom. You can see kind of what you haven't submitted. It should be entered in probably today after school, so that way tomorrow you can kind of see what you stole me. But by the end of the week, I want it turned in. We're going to take a few notes today based on optimization story problems. I only have one problem I'd like to go through, but if we need more, I'll go through whatever type. The different types of optimization problems that I'd like you to be comfortable with that you can answer. Number theory. So one of the number theory problems, like if the sum of two numbers is 17, and what is the biggest product that you could potentially have between them? That type of thing. Or maybe it's the difference of these two numbers. You have to set up your equation, then figure out maybe you're trying to optimize the product. And so the product is the formula you take the first derivative of. Remember, you always have to substitute and get it down to one variable. Now, the other types of problems you could have, something with area or perimeter. That was a big one. We had a lot of those. That's one of the examples I want to cover today. Just one example. And then the last type of problem that we have is revenue. That's where if you're going to optimize the price of an object that you're selling, where you're going to lose a few customers if you bump up the price a little bit, but maybe it's worth it because maybe you'll make more money in the long run off of the few sales you make. So that's what we're going to look at today. My goal is just do one. I have an area perimeter kind of problem picked out. Once we're done, finished, complete, then the rest of the time is yours and you can work on your assignment. The assignment's due on Wednesday this week. Okay, what is touching me?
Hey, you think we'll have school on Thursday?
Why wouldn't we?
Snow.
When?
Massive storm coming.
I haven't even heard. Honestly, I haven't. I'll check it out later.
No, it's stupid.
Didn't even know.
That we get storms on the weekends. That's so dumb.
Weather doesn't wait for you. So, thanks. Okay, all right. Let's take a few notes here. All right. So, okay, first example here, or I guess. Okay, all right. Anyway, okay. Shh. So, hey. Shh. Okay, all right. We got a rectangular field. We're going to divide it into two fences. I believe you have one of these in your homework today. And so this one's talking about 1,000 feet of fence being used, and we got to figure out the maximized area. So that's the formula we're going to be that's the formula we're taking the first derivative. We are maximizing the area. This tells you what you're taking the first derivative of. That's the hardest part for most people. Is like, well, I don't even know what to take the derivative of. It's what you're trying to maximize or minimize. So I'm doing the area formula. So we'll get to that here in a minute. Now, here's the idea. On this particular problem, we have 1,000 feet of fence, and we're going to be dividing it. We're dividing it into two separate pins here. So we have a rectangle of some type. I have a kind of picture there. You will have no pictures for yours. I just give you the story problem. These pictures are just generic. I found on Google anyway. So you're going to be dividing it down the middle with, so it has two fences. I don't care which direction you go. It's the same numbers anyway. So these numbers are all X's, and then the other distances are Y's, going across. Now, I have a total of 1,000 feet of fence. So that means when I add up all the X's and all the Y's, I get 1,000. So on my next problem here, on my next slide, let's go through that. So same exact thing. I'm going to add up my X's here. And this formula just represents my perimeter. This is not the area formula. So I have 1,000 feet of fence. I'm going to solve for one of these letters. Okay, so solving for one of these letters, this is 3x plus 2y equals 1,000. I'm going to solve for y in this case. It really doesn't even matter which letter you solve for, because you can take the derivative of any type. So I'm going to move the 3x over and then divide everything by 2. Now when you do this, you don't need to actually divide them by 2. You can, if you want, make them decimals or whole numbers. It really doesn't matter. As long as you know what you're going to do with that problem, that's all I really care about. So all I've been doing here on this particular problem so far is just worrying about the perimeter. All right, so we have a perimeter. All right, so what we're going to do here is we're going to try to maximize the area. Now, on this particular problem, I have no idea what the area is. That's kind of the goal. It's like figure out what the dimensions are so I can figure out what the biggest area is. Area is just length times width. My dimensions on my problem were just x times y. That was the area of the entire field, right? It was x in width, y in length. All I'm going to do here is substitute in one of the letters because I don't like to have two variables here. That's the whole reason why I use that other perimeter formula for my, my rectangular fields. So I'm going to plug in what y is. Y is a 1,000 minus 3x divided by 2. And so this is my area. Okay, now. So here's the idea. We've got to the point where I found my area formula. Now, I would probably just recommend, let's just simplify this before we move on, like distribute and everything before I take the first derivative. Because remember, we're trying to maximize area. So I need to take the derivative of this red formula. But before I do that, let's actually distribute the x through. Remember, when you distribute the x, it's going to the top only because it's technically x over 1. And when you multiply fractions, you multiply top to the top, bottom to the bottom. So it's going to end up being 1,000x minus 3x squared, and then this is all over 2, which each item is over 2 by themselves. That's a law of division. You can do that. Okay, does everyone understand what I just simplified there? I haven't taken the derivative yet. I'm simplifying this thing down so I can actually take a derivative later. We're good though? Now, once we're done here, remember the goal is to figure out what my dimensions are. So it's to figure out x and y. So at some point, I'll probably have to come back to this perimeter formula just to plug my numbers in. Then I also have to come back to the area because it does actually want to know what is the maximum area. That's every problem. It wants to know what your pairs of numbers are and what that maximum was. So you have 3 numbers you have to type in Google when you type these in. That's all you have to do. You don't have to show me all the work. You have to type in your 3 numbers, your 2 pair of numbers. In my case, on this one, it's my length and width, and then what the maximum area was. That's really what I want to see. That's pretty much how it goes for almost every problem. I think the only ones that would be different, like the revenue problem with like, I think I picked an airplane problem like you guys had earlier last week, where you have to maximize the price of the ticket. So one of the numbers would be tickets, the other one would be passengers on the plane. And you try to figure out what your 2 numbers are and figure out what your total revenue is. So we did some of those. So if you had notes from last week, it should be super easy because all I did was change the numbers. That's all I did. So, all right, let's do the first derivatives here. So let's kind of go into this. So we're going to do the first derivative of the area formula. So I'm going to rewrite this. This area formula that we just got done writing was 1,000x divided by 2 minus 3x squared divided by 2. So this is the basic formula. I'm going to take the derivative of this thing. So first derivative, what do we get?
500 minus 3x.
Yeah, 500 because the x would disappear, right? And 1,000 divided by 2 is 500. The x just disappears, right? Because you drop the 1 out front. And then for the next part, what do you say?
Negative 3x.
Negative 3x. Because when you drop the 2 out front, it's 2 times 3, and then you have to divide by 2 on the bottom. So the 2's actually ended up canceling, so it's just 3x. Okay, questions with the area. That's the first derivative. Drop the 2 out, cancel the 2's. On the other one, the x just went away because it was 500x, basically. All right, now to simplify this thing, basically what you got to do is you got to...
Wait, never mind.
You got to set this thing equal to 0. And then solve or factor it. I don't know how you want to think of that. I'm just going to set it equal to 0. Move the 3x over, divide by 3.
Why didn't the x stay on that 1,000?
Because when you take the first derivative of it, you drop the 1 out front on the x because it has a 1.
Initial. Oh.
Because we're taking the derivative of each piece.
Okay, so you just divided by 2 and then did the derivative.
Yeah. Yep. Yep. All right. And so my x ends up being 500 divided by 3, which... what is that, 100 and something? 166.6 repeating. All right, so there's my x dimension for my field. That's I just solve for x. Again, how I actually figure out the maximum. After you take the derivative, you either factor it apart and solve, or you just set it equal to 0 and solve. This one I just set it equal to 0 because it was easy. I didn't have to factor anything. So now. What I'm going to do is I'm going to take this thing and go plug it back into the perimeter formula. So if you don't remember what that perimeter formula was, let me just write down perimeter here. The perimeter formula, if you go back a couple slides, it was this. This is what we had earlier. This was my perimeter formula. I'm going to take my x and plug it back in. So
that's why.
250.
Yeah, so I think you're right. So if I plug this back in, plug in my 166.6. Shh. So we plug this back in. If I actually multiplied the 166.6 times 3, I get back to 500. That's, you know, if you used a repeating number and you try to go as far as you could. So I'll subtract the 500 across to get 500. And just like you guys were saying, when I divide by 2, your y should be a 250.
So weird that we had y equals blah blah blah, and we actually solved for x.
Yeah, because I substituted that in, because we substituted what the y was. I just want to get down to one variable. You could have solved for x and, you know, plug that in. But anyway, so we got our 2 dimensions. So this is a part of the question. When you answer your Google questions today, it wants both pieces. It wants to know what your x dimension was, what your y dimension, or whatever variables you chose. I have both, and now we have to figure out what the area was. The optimum area on this problem is if you were to multiply these 2 dimensions together. So 166.6 repeating times 250, that should give me my number. So I'm gonna I typed in a few 6s here on that problem, so just so I can see what it would do. 41,666.66 basically, and I'm going a few decimal places there, but that's the area, and that's going to be, I think this is in feet, right? So it's feet squared. So this was feet, and this was feet earlier. So, all right, but this is the optimum area that we're getting. That's the biggest area for both fences. If you want to figure out what the actual, like, 2 individual pens are, just divide it by 2.
Is there a repeating number on the calculator?
No, you just have to
not
type
that I know. If you just type a bunch, I typed in like 4 or 5 of them.
Oh, I typed in 7.
4.
I just have to go.
I got bored.
Yeah.
Yeah, I'm about it.
Take it, board.
I
typed in 13.
What?
How many problems are we doing today?
That was it. That's all I wanted to cover.
Okay.
So if you want me to, I can cover any type of problem though. But I think if you have the notes from last week, you should be fine. You should have one of every type of problem that I assigned. The problems look identical to the ones I gave in class. I just changed one number. So it should be pretty straightforward. You should be able to able to solve it. You are going to get weird decimals. It's going to happen like this. I consider this a weird decimal. They're not going to be just all nice, pretty numbers every time. So don't be afraid of that. Remember, I want 3 numbers on everything you submit. Whatever your 2 dimensions are, and then whatever you're trying to maximize, area, product, revenue, whatever it's asking for. But those are the types of problems. Again, here's the other slides we did last week. Number theory problems, the airline, problem where you had revenue. We had problems where you had to like maximize a garden. I think we had a problem where you had to maximize the area if there was like 3 walls on a fence up next to a barn, and the barn ended up being way too big, but you guys got the idea. But yeah, so these are the types of problems you're going to have today. But I'm going to stop it there. So I got a lot of editing to do.
What do you mean?